This is Math 2, Unit 4, Lesson 2, 4.2 notes for math. You should have this copy in front of them, a copy of this sheet of notes in front of them already, as well as something to write with, your packet that was given to you last week. That's this packet here. You should have this packet out, these notes out, a calculator out, and of course something to write with. Okay, perpendicular bisectors is what we're talking about right now, or for today. I'm going to put a note up here, and I'd like you to do the same. These are notes 4.2. So when you organize this in your notebook or your notebook binder, wherever you keep your notes organized, you know where to put it, 4.2. And again, notes, so you know this is not getting turned in as homework. All right, even if you can't read it up on my screen, you have it in front of you. We're going to first talk about the perpendicular bisector theorem. Perpendicular bisector theorem, which states, if a point lies on the perpendicular bisector of a segment. Let's take a step back. What is a perpendicular bisector? We know to bisect means to cut something in half. So it's a bisector that is also perpendicular. So if a point lies on the perpendicular bisector of a segment, then it is equidistant from the endpoints of that segment. Okay, so what that means, let's write this down. If AB, that's this segment, this is the segment they're talking about, perpendicular to DC. DC is the perpendicular line, perpendicular to the segment AB. If AB is perpendicular to DC and AD is congruent to DB. Okay, so if AB is perpendicular to DC and AD is congruent to DB, so I'm going to put markings in there, then AC is congruent to CB. Now we can actually prove this, if we actually will be proving this eventually. This is always true because if you look, I'm going to write this in pencil because I am going to erase this so it doesn't get too messy. Can you see that I have the big triangle, but when I cut it with this perpendicular bisector, I have two smaller triangles. They have a congruent angle because if that's 90, this must be 90. They have these two congruent sides. Reflexive property means that these are the CD is congruent to itself. Then the two triangles are congruent by side, angle, side, which means corresponding parts of congruent triangles are congruent. And we actually will be proving that in homework eventually. Again, they gave to us that this is perpendicular to this segment, which means that these are both 90-degree angles. They're congruent to each other. They gave us it's a bisector, so AD is congruent to BD. We know reflexive property. CD is congruent to itself, which means the two triangles are congruent by side, angle, side. And because the two triangles are congruent, corresponding parts of congruent triangles are congruent, which means that AC is congruent to CB. Now, like I said, I was going to erase. This is true for any point that lies on the perpendicular bisector. For example, I could put a point down here, and if this point lies on the perpendicular bisector, the length from, let's call this point P, P to A and P to B are going to be congruent. So I'm making another isosceles triangle in there. Can you see that? So this is congruent, CA and CB, as well as PA and PB. So I can even draw, if I were to extend this perpendicular bisector, I can draw any number of triangles, and these are always going to be congruent. These legs here. It's always going to make an isosceles triangle. All right, so what is this saying? If a point lies on the perpendicular bisector, so I showed you the point that was given, we put point P, this could be point Q, any point on the perpendicular bisector of a segment, here's the segment, then it is equidistant from the endpoints of that segment, equidistance. All right, converse of perpendicular bisector theorem. If a point is equidistant from the endpoints of a segment, then it is on the perpendicular bisector of the segment. So if they give us, if a point is equidistant from the endpoints of a segment, so here's the point, if it's equidistant from the endpoint of this segment, that means this point C lies on the perpendicular bisector. If AC is congruent to BC, all right, so that's the markings I just put in there. If AC is congruent to BC and CD is perpendicular to the segment AB, then what must be true? It's this is a perpendicular bisector, so that's going to be perpendicular, and these little segments here will be congruent. Then AD is congruent to DB. Then these little segments here, it's a midsegment or bisector. It bisects AB. All right, another quick side note we're going to write over here is, first off, recognize that we're dealing with isosceles triangles here. Can you see that? Isosceles triangle, perpendicular bisector. So when we have a perpendicular bisector, any point on the perpendicular bisector is going to be equidistant to these endpoints, meaning it's going to make an isosceles triangle. So a little side note we're going to write over here on the side is, write it with me, the perpendicular bisector is also an angle bisector. When it is an isosceles triangle. All right, so when you have an isosceles triangle, again, which is what we have over and over in all of these pictures, and you drop its perpendicular bisector, meaning it's perpendicular to the base side here, you drop its perpendicular bisector, so it's perpendicular, it cuts it in half. This perpendicular bisector will always bisect those angles in there as well. It's going to cut these little angles, and it's the same part that we said earlier, because corresponding parts of congruent triangles are congruent. If that triangle is congruent to that triangle, then corresponding angles are congruent. So it's also, an angle bisector as well. We'll see that a little later. All right, so that is perpendicular bisector theorem and the converse to the perpendicular bisector theorem, definitely on the test. Okay, next piece that is also on the test is called the circumcenter. The circumcenter of a triangle. The point of concurrency, which is the intersection of the perpendicular bisectors of the sides of a triangle. I'm going to read that again. The point of concurrency, starting over, circumcenter is the point of concurrency of the perpendicular bisectors of the sides of a triangle. All right, so this is not an isosceles triangle, it's just an average everyday triangle. If you were to go through and draw all of the perpendicular bisectors, let's say we had our construction tools out and we constructed the perpendicular bisector of this segment right here. I'm going to put a little perpendicular marking, and I'm going to extend that line. You do not have to. I'm just wanting to show you what it looks like. So we had our construction tools, we're pretending, and we constructed the perpendicular bisector here, which means that these legs are segments. These segments are congruent. All right, and then we still had our construction tools out, and we made a perpendicular bisector here. Constructed it, and I'm going to, oh, it means it's perpendicular here. I'm going to connect, and I know this is congruent to this. And then we still have our tools out. I construct the perpendicular bisector of this segment. So this is perpendicular. These little segments here are congruent because that's what a perpendicular bisector does. It is perpendicular and it bisects. It cuts it in half. I'm going to extend this. So again, we're pretending we have our tools out and we made this. Once we found all three of them, they will always intersect at one point on any triangle. When you draw the perpendicular bisectors of each segment individually and extend them out, they will always intersect at one point. Okay, so like I said, don't draw that in there because I am going to erase it. If you did already, that's fine. So after we find those and they all intersect, we call that the circumcenter. You will need to know that for the test. I will show you what it's going to look like on the test. So the circumcenter is the point of concurrency of the perpendicular bisectors of the sides of a triangle. So let me show you what it's going to look like on the test. This is off of a review worksheet, but it's very similar to what you're going to see on the test. So do you see these 4 triangles? We've only done one. We just did one right now, and that was the circumcenter. We'll learn the centroid, orthocenter, and incenter throughout the week. So you're taking the test, so let's just focus here because this is the only one we've learned so far. Circumcenter is the point of concurrency of the perpendicular bisectors. So that's what you're looking for. You're looking for perpendicular markings, which is that marking there. And you're looking for bisector markings, which are the tick marks like so. So you're looking for those 2 markings together in one of these 4 triangles. So I look here and I see bisector markings but no perpendicular corners, so it's not A. I see this one and I definitely see perpendicular corners markings there but no bisecting markings, so it's not B. I'm going to jump over to D. I see no perpendicular markings, no bisector markings, and I see angle markings, which I'm not even dealing with angles right now, so it's definitely not D. So let's look at C. There's my perpendicular markings. There are my congruent markings. So this is definitely, C is the picture I would match with the point of concurrency of the perpendicular bisectors, known as the circumcenter. So you don't have to memorize, oh, circumcenter is the point of concurrency of the perpendicular bisectors. They will give you that. What you have to know how to do on the test is how to match this with this picture. All right, we'll talk more about this as we go throughout the week, as we cover each one. So if you're a little nervous on it, don't get too nervous. We will go over this a little more. Okay. Back to our notes. The circumcenter is equidistant from the blank of the triangle. All right, so let me erase all these extra markings I put in there. And again, if you did them already, that's okay. Okay. So I want to put back those marks because those are congruent. And my little perpendicular to show you again, that's what you're looking for, perpendicular bisectors. All right, the circumcenter is equidistant from the blank of the triangle, from the vertices. Vertices of the triangle. What that means is, here's the vertex, here's a vertex, here's the vertex. I have 3 vertices in any triangle, the 3 corners. From each corner to that circumcenter is going to be equidistance. Now those lines you can go ahead and mark on your picture. So it's the point from the circumcenter, that point there where they all intersected, out to each corner of your triangle. The circumcenter is equidistant from the vertices of the triangle. So that means this is congruent to this segment and this segment. 1, 2, 3. Those 3 segments are congruent to each other. All right, moving on. Find MN. Now I purposely did not put anything in there because I don't want anybody working too far ahead, and I want you staying with us. So let me give you the information needed. 4x plus 19, and this side on the right is 6x minus 7. Okay, so look at the images that's given to us. Nowhere did it say anything about these legs being congruent, so I cannot just say, oh, set them equal, because there's no markings there. Can you see that? No markings whatsoever. But can you see that this is the PN is the perpendicular bisector of MO? Do you see that? Perpendicular bisector, which means any point on the perpendicular bisector is equidistant to the endpoints. So even though they did not mark it for us, we can say yes, indeed, they are congruent. And the only reason we can do that is because of the perpendicular bisector theorem. Perpendicular bisector, a point on the perpendicular bisector is equidistant to the endpoints. It is an isosceles triangle. 4x plus 19 equals 6x minus 7, and we solve. Subtract your 4x. (19) equals 2x minus 7. Add your 7. Go ahead and do that now. (26) equals 2x. Divide both sides by 2. X equals 13. Now be careful in the test when you're working this one out and you see 13 there and you're like, oh, I got it right. Distractors. You didn't make a mistake, but if you stop here, that's wrong, because they didn't ask me just for X. They asked me to solve for MN, which means I'm not done. MN equals 4x plus 19, 4 blank plus 19. X we just found to be 13, so go ahead and calculate. Okay, 4 times 13 is 52. 52 plus 19 is 71. So MN equals 71. All right, next one. Find JL. Now JL down here is the base. I know I haven't given you any sides yet. I will give them to you in just a second. JL is the base. Do you see that? I have this isosceles triangle, but no markings down here. Do you see that? But the converse of the isosceles triangle tells us, the converse of the perpendicular bisector theorem, that's this one right here, tells us that if a point is equidistant from the endpoints of a segment, these here are equidistant, then it is on the perpendicular bisector of the segment. So that means this here is the perpendicular bisector. All right, let me give you the information needed. 3x plus 4 and 5x minus 16. All right, they're asking us to find JL. Now, because we use the converse of the perpendicular bisector theorem, we now know that JM is congruent to LM, so we can make our equation 3x plus 4 equals 5x minus 16. I'm going to give you guys a few seconds to solve that on your own. You're trying to find x. All right, I hope everyone got it. X is 10. Okay, and again, I'm going to put stars over here because this is our final answer. I did box this in. 13 helped me find the answer, but this is the final answer. Same thing here. 10 is going to help me find my final answer, but it's not what they're asking for. All right, they're asking me to find JL. Does everybody see that? And I know that JL equals JM plus LM. Do you guys agree with that? It equals this side plus this side. So I can say it is 3x plus 4 plus 5x minus 16. Or you can just plug it in and double it. You could do that as well. If that's the way you'd like to do it and check with my answer at the end. 8x and 4 take away 16 is negative 12 because I'm combining like terms. JL equals 8 times 10 because that's what x is. 80 take away 12. JL equals 68. So hopefully you got the same thing. If you did, you can check it right here. 3 times 10 is 30. 30 plus 4 is 34. And if you double it, 34 and 34 is indeed 68. All right, moving on to the back side. All right, RT bisects SU, find each measure. Okay, so RT, here's RT, and it bisects SU. Here's SU. It didn't say it was a perpendicular bisector, but they already put markings in there. So it's perpendicular and it bisects. So let's go ahead and put those congruent markings in. So indeed, even though it didn't use the words, SU is the perpendicular bisector of RT. Why? Because it gave it to us that it bisects, and they gave us that perpendicular marking. Okay, which means I have two isosceles triangle. I have isosceles triangles. I have this one up here where RS is congruent to RU because it's an isosceles triangle because this is a perpendicular bisector. And same thing here. I have ST is congruent to UT. Same reason. This is the perpendicular bisector, which means these are equidistant. All right, let me give you the information because you do not have everything you need. ST is 23, and I lied, sorry. UT is 23, and VU is 5. Those are the markings that should be given. All right, so let's see what we can find. ST is this segment here, and yes, I know I gave it to you accidentally, but can we see that because this is a perpendicular bisector, we have congruent segments here? So ST is congruent to UT, so ST is 23. All right, SV, where is SV? That's this segment here. Now, it's not part of my congruent legs like these here, my isosceles triangle legs, but since they did tell us that it's a bisector, that RT bisects SU, then these are congruent. So SV is equal to 5, again, because those two are congruent. And SU is all of it, so if this is 5 and that is 5, 5 and 5 is 10. Okay, next one. Find X. Now this is requiring us to use what we learned on the other side. First, let's take a look. There's two right triangles in here, and it's a perpendicular bisector. Do you see that? I'm going to erase that marking there. This is a perpendicular bisector to this segment. This segment here is a perpendicular bisector to this segment here. Can you guys all see that? Bisector, perpendicular. Which means these legs are congruent, which means it's an isosceles triangle. All right, so again, can everybody see that this is a perpendicular bisector, which means any point on the perpendicular bisector is equidistant to the endpoint. So these two legs are congruent, which means it's an isosceles triangle. I'm going to flip back to the front. The perpendicular bisector is also an angle bisector when it is an isosceles triangle. And we do have an isosceles triangle, and we do have a perpendicular bisector, which means it is also an angle bisector. So that gives us 12x plus 5 equals 4x plus 21. So go ahead and solve that now. 12x plus 5 equals 4x plus 21. All right, x equals 2. And on this one, we don't have any plugging in to do because all it said is find x. Find x, x is 2. We're good. All right, next one. QT is the perpendicular bisector of PR. QT is the perpendicular bisector of PR. Find each measure. All right, so there's more information I need to give you. I'm going to give you that this segment right here is 2y plus 5. And this segment down here is 7x minus 17. Okay, I'm going to cover. Do you see that we have a big triangle up here? Don't look at the small ones. Look at the nice big one. And that QT is the perpendicular bisector. So they didn't put these markings in there, so I'm going to put them in there now. Bisects means to cut in half. And since it is a perpendicular bisector, any point on the perpendicular bisector is equidistant to each other. Now I'm going to have to fix my markings only because when I covered that one already had one. So I'm going to make this one a 2 and this one a 3. Okay, so these are congruent to themselves because it told us it is a bisector and it's perpendicular, which means it's an isosceles triangle. Any point on the perpendicular bisector is equidistant to the endpoints of this segment. Therefore, 5y equals 2y plus 5. Y is not the first thing they're asking for, but that is going to be the first thing that I solve. Sorry, 5y minus 31. 5y minus 31 equals 2y plus 5. Go ahead and solve that now. All right, everyone, I hopefully got y equals 12. Now, keep in mind, if I'm going too fast, or if you're not getting the same answers I am and you're trying to fix it, these will be online, so you can always go back and double check and replay it to see what's going on. Okay, y is 12. X, I'm going to go back and find X. X is here. They gave us congruent markings already, so we know they're congruent. There's not much extra work there needed. 4x plus 4 equals 7x minus 17. Go ahead and solve. Again, I got that from down here. Okay, hopefully you ended up with x equals 7. Okay, PQ. Where is PQ? PQ is here, and I've officially run out of room, so I am going to put an arrow that the rest of my work's going down in this blank spot at the bottom. Okay, PQ is what they're asking us for next. PQ with no segment, remember that means the length of. This is saying find the length of PQ. PQ is 5y minus 31. We just found y to be 12, so 5 times 12 minus 31. Plug it in your calculator or do that by hand. And 60 minus 31 is 29. So PQ is 29. Okay. Next piece they ask us for is QR. Now technically we know the length of QR should be equal to the length of PQ because that's the way we set it up. We set it up that these two are congruent to themselves, to each other. But this is a good way to double check your work to make sure that you've done everything correctly. So what are we plugging in for y? The same thing we did over here, which is 12. So plug it in your calculators or calculate it by hand or in your head. QR equals 29. Check. Ended up the same. We're good. Okay, PS. PS is down at the bottom. It's here, and that is 4x plus 4. And we already found x, and x up here we know is 7. So you're plugging in 7. 4 times 7 plus 4. Go ahead and calculate that. Okay, we end up with 28 plus 4. So PS equals 32. SR, again, that would be more of a double checker. Because I'm running out of time and space, I'm going to accept it for now. But I would suggest that on the quiz or test, you plug it in if you have time. We know that PS is going to equal SR because that's the way we set the equation up. This equals this. PT, where is PT? PT is here. And it equals 6x minus 2y. 6x minus 2y. 6 blank minus 2 blank. X we found to be 7. Y we found to be 12. So plug it in your calculator or do it by hand or in your workspace. PT equals 18. And you do have one like this on the test, by the way, with all this work just like this one here. Okay, last piece is PR. All right, what do we know about PR? PR is double PT, right? What did we just get for PT? If this is 18, then this is 18 according to our congruent markings. And we know that because it's a bisector, this is congruent to this. So 18 plus 18 is 36. If you want to put a little note here, you got that because you did 18 plus 18. All right, last one, TU. UV or VY and UZ is what we're looking for. What's given? Z is the circumcenter of the triangle TUV. Find each measure. Remember, a circumcenter is made from all the perpendicular bisectors. I'm going to flip the page really quick. The circumcenter is made from all the perpendicular bisectors. All right, so that means all these perpendicular segments are also bisectors. So those are congruent. So what is that? VY and UY, UX and TX are congruent. TW is congruent to VW. How do we know that? Because the circumcenter is made from the perpendicular bisectors. All right, TU. Where is TU? TU is here. And let me give you the information because I did not give it all to you yet. This segment here, VU, all of this is 34. And XU is 19. All right. These markings here, the ones that I put in blue, those will be given to you. I just purposely took them off the notes to keep all of us working at the same pace. But on your assignments and quizzes and tests, those numbers will be pre-printed for you. Okay, TU. Now we just said that these are congruent. So if those are congruent, that means this is 19. So TU equals 19 plus 19. So excuse me, TU is 19 plus 19. So again, do it by hand. What does that come out to? 38. TU is 38. Okay, VY, where is VY? VY is here. Now, I don't know this segment here to know what this one is, but I know all of it is 34. If all of it is 34 and it gets bisected, that means these two must be the same and add up to 34. So cut 34 in half. And that equals 17. So this is 17 and this is 17. So VY is 17. All right, UZ, where is UZ? UZ is here. This is the point from the circumcenter to the vertices. Now, what did we say earlier? The point from the point of concurrency, oh here, the circumcenter is equidistant from the vertices of the triangle. So from the vertex to the circumcenter, vertex to the circumcenter, vertex to the circumcenter are all going to be the same. That means, I know I have a lot of congruent markings here, so let me keep track. That means that this is congruent to this, is congruent to that. Let me put them in the same color pen that I used earlier. The circumcenter out to the vertices, out to the corners of your triangle will always be equidistant. They will always be the same length. They will always be congruent. So they're asking us to find, I'm just darkening it just a smidge bit more. All right, they're asking us to find UZ. Where is UZ? And we know that UZ is congruent to TZ. We don't know what TZ is. It's also congruent to VZ, and VZ is 21. Therefore, UZ is also 21. All right. I know that was a long lesson, a lot to digest, but these will definitely be on the test. So if you will please take out your packets really quick and open up to worksheet 4, Unit 4, Worksheet 2. That's this one here. Make note that what I want you doing today are numbers 1 through 12, I believe. Yes, numbers 1 through 12. The rest, 13, 14, and 15, we'll do together when I come back. All right, so what is it that you're going to be expected to do? This part here, this first part is from the notes. 2, 3, 4, and 5 are review. That's from last week's lesson. Distance formula, midpoint formula, slope formula. So that is all review, and I lied. It's 3, 4, and 5. Numbers 1 and 2 are from today's lesson. Okay, so let's do this 6 and 7 together. When 3 lines meet all in one point, they are called blank. The point where they meet is called the point of blank. I want to do these with you because I did them in notes, but not exactly worded this way. When 3 points meet, they are called concurrent lines, or concurrent, sorry. When 3 lines meet all in one point, they are called concurrent. The point where they meet is called the point of concurrency. Number 7, every point on the blank of a segment is equidistant from the blank of that segment. Every point on the perpendicular bisector, this is from our notes, every point on the perpendicular bisector of a segment is equidistant from the endpoints of that segment. Okay, so we did 6 and 7 together. You're doing 1, 2, 3, 4, 5, 8, 9, 10, 11, and 12. That's what you're doing today on your own, bringing it in tomorrow with any questions to get cleared up.